Hello everyone, and today we are going to have our quick lesson here on acceleration 1.3. We've briefly talked about it a little bit earlier, and so now we're going to kind of tie some of those ideas together and maybe clarify some potential problems we could be having. So let's first start with our purpose. So these are really the three main things I hope to accomplish in this video, and things you should be leaving this video understanding. Purpose one is you should be able to know the difference between acceleration and speed or velocity, right? So see how they're connected, but more importantly, what is different between them. Number two, know what unit is used for acceleration. So you want to know, how do we actually attach that unit? How do we measure that acceleration? I know the next piece would be how speed versus time graph is different than that of a distance versus time graph. All right, we've talked about them, and we're going to see how they now are similar, but also very, very different. So what is acceleration? So acceleration is the rate at which velocity changes. Now there's one piece I want to make sure is really clear here, and that's just the idea that I very deliberately put velocity there. Velocity is there quite simply because, well, let's recall what velocity is. Velocity is the speed plus a direction. So what that means is, per the definition of acceleration, we have acceleration if we have an increasing velocity, if we have a decreasing velocity, or, and this is the one that a lot of people forget about, a changing in direction. All right, so what that ultimately means is I could be speeding up, I could be slowing down, or I could simply be just turning. And that would be a form of acceleration. All right. So if we kind of continue on with this, how do we actually measure that acceleration? We measure acceleration using the unit meters per second squared. Now, one thing I want to make sure is clear, because you'll see this in a couple of different ways. Meters per second squared is kind of the classic unit will attach. But there's two other ways you'll see it. I want to make sure you recognize these other two. So this is the first way that you'll see it, all right? Now the second way is going to be meters per second per second. All right, you'll frequently see this sometimes in text, or you'll see it as kind of like the expanded version of meters per second squared. Sometimes you'll see it if, like, personally, like if I don't have access to a text editor that allows me to do that kind of superscript 2. So you'll see me write it that way sometimes. The third way you'll sometimes see is meters per second, and then you'll see this little pointy symbol, and then you'll see the two following. You'll see this again if I can't do that upper two, that squared part where it's kind of, a superscript where it's up a little bit. You'll see me write it out like that sometimes, especially in some like Google Forms or things like that, where I just can't write those out as of yet. Hopefully Google Form adds that for me in the future. I think they're working on it soon. So until then, you may see that. So I want you to recognize all three of these as possible units, because they're all ones you will see whether by me or just in general. So what does this unit mean? This unit means that for every second, our velocity changes. So for every second that goes on, our velocity increases or decreases by a certain amount. So let me clear that out here. All right. So if we take this a step further, and now one little clarification here on this question, we're assuming that our car here, I didn't specify, but I'm going to add that to it, is at rest, right? Which means not moving. Okay. So if I'm in a car that has an acceleration of 10 meters per second squared, what will my speed be after each second? So assuming we're starting from 0 meters per second, what is my speed going to be after each second? Well, if I have an acceleration of 10 meters per second squared, that means for every second, I'm going to increase by 10. So if that's the case, I'm going to have 10 meters per second, 20 meters per second, 30 meters per second, 40 meters per second, and then 50 meters per second. All right, so each second I increase by that specific amount. Pay attention to the units here. I very specifically have meters per second because we are reporting a speed. In this scenario, we are not reporting an acceleration. In this scenario, my acceleration is constant because I go up by the same amount each time. So how do we actually go about calculating acceleration? So some important pieces here. So the first piece is if, let's get a different color here. So if you are increasing your speed, that means your acceleration is positive. If you are decreasing your speed, that means your acceleration is going to be negative. All right. So a positive means you're speeding up. Okay. A negative means you're slowing down. Okay, and we use the equation acceleration equals final velocity minus initial velocity. Order matters. Don't flip this order or you're not going to end up with the right answer. And then over time taken. Final velocity meaning ending. Okay, not necessarily the greatest. Okay, just whatever your last velocity is. And initial being starting. All right. So, let's use this in a practice problem. If I get in my car and I start driving, my starting speed was 0 meters per second, my final speed was 20 meters per second. If 10 seconds passed, what is my acceleration? I'm going to break this down into really 3 steps. So then that way, I would say always when you're working on these, break it down to these 3 steps, because that's going to help make sure you don't have a calculator error, and it just reduces the chances of you accidentally mistyping something. Or if you make a mistake, it's easier to find that mistake, so it can save you time. So the first thing is find your change in speed. So I'm going to have 20 minus 10, because I have starting at 0, right? So if you want me to add a little color code here, my 0 here is right here. And my 20 here is right here, which is going to give me 20 meters per second. Always do a quick logic check here. Am I speeding up in this question or am I slowing down? Right? I'm increasing my speed. I'm accelerating in a positive way, which means it makes sense that my number here is going to be positive, right? So that makes sense. Always double check that, because then if it doesn't match, that means you probably subtracted these in the wrong order. Second step, change in time. For this one, we're starting from 0, pretty straightforward. We're going to have 10 seconds. We can find my acceleration, so we're going to do 20 meters per second, divide by that 10 seconds, leaving us with 2 meters per second squared. And all right. And let's do our second problem. I'm now traveling 20 meters per second, but I stop at a stoplight. If it took me 5 seconds to stop, what is my acceleration? All right, so my first step, okay, I know this one's a little tricky, right? It's still the change in speed, but now it's 0 minus 20. Again, order matters, all right? So in this scenario, my starting speed, my initial was 20 meters per second. That's what we're saying. We're already moving that speed. Now I'm slowing down. So that's why my 20 is here. My ending, as I said, I stopped, but I stopped. So that tells me it's 0. So this will be 0 here, which is why we get a negative number here. Again, logic check. Does that make sense? Am I slowing down or speeding up? Well, I was moving and then I stopped, so I slowed down. Number should be negative. Great, that matches. Let's move on to the next step. Next step being looking at that time. I said it took me 5 seconds to come to that stop, so there's my time that happened. And lastly, I have my acceleration, in which I'm going to take my negative 20 meters per second, divide by that 5 seconds, and I have a negative 4 meters per second squared. Again, that makes sense because I'm slowing down, so I should have that negative number. Now, real quick, when we're looking at graphing acceleration graphs are known as speed versus time graphs. Time goes on the x-axis. Time's always on the x-axis for these graphs. Speed goes on the y-axis. That's your vertical axis. Speed's going to go there for these graphs. which means we find the slope. Remember, the slope is just that steepness of the line. All right, so if we find the slope of the line, we actually find the acceleration. All right. So what that could look like if we have that graphing example. So in the one we have here below, data on the left, graph on the right, you'll see it set up kind of how we typically have it. And in this scenario, we have an acceleration of 5 meters per second squared. I know that because just quick looking at the table, I'm going up by 5 each time. Like for every second, I'm going up by 5. And that's what gives us the straight line we have here. If you have a straight line in a speed versus time graph, you have a constant acceleration, but a changing speed. And that's something that's different than our distance versus time graphs. Our distance versus time graphs, a straight line means a constant speed. So really be careful. Whenever we are looking at a graph, the first thing you should do, especially with what we're discussing right now, is immediately first thing, look for what is here. If it says speed, all right, make sure you're looking at those different points as speed. If it says distance, make sure you're treating it that way. Number one mistake I find is people not paying attention to what's there, and then they have a real hard time figuring out what's going on with the motion of that object. All right, so that ends our video on our 1.3 acceleration lesson. If you got questions, absolutely let me know. Have a great day.